now explain the motivation for memory order consume. And as expected, it's about improved performance. In some programs, including the Linux kernel, there are data structures which are rarely modified and frequently read by multiple threads. And as we will see, there are situations when we can improve the performance if we don't use normal release and acquire. This is especially for modern architectures such as Power, MIPS and ARM, but it's also for x86 where better compiler optimizations can be used. Okay, so this data structure in the Linux kernel is called read copy update. And I should also point out that I will not ask about anything about this in the oral exam. That is, I mean, it's a different course, but I think it's interesting to have this background of the memory order consume anyway, but I will not ask about it. Okay, so how it is organized for read copy update in the Linux kernel is as follows. This is an alternative to readers writers lock. A readers writers lock is a lock where multiple threads can read a data structure. So there can be multiple readers in a critical section, but they are obviously not allowed to modify anything, only read. Okay, and alternatively, if there are no readers, there can be one writer. But with this read copy update, there can be multiple readers and a thread can update the data structure, but not the real data structure, only a copy of it. And then when all the readers are done, the copy can be moved into, it can be made available as the new real data structure. Okay, if you are interested in lawsuits and the Linux kernel, you may want to read about this. As a parenthesis, this company said that the Linux kernel violated a patent and they wanted royalty from all big companies. Well, not only big, but starting with the big ones. And now they don't exist after this lawsuit. Okay, so what is this about? Well, if we have this RCU data using RCU, and we want to get some data from this data structure and then add it, as we do here, we read this Q from it and add an attribute of Q to a global variable B and return that as a value. Okay, so if we rewrite this in terms of standard C or C++, then without consume, we would have to do an acquire. And what would that result in? It would result in preventing the compiler from reading B before the acquire. Recall, in a pair of acquire and release, no one is allowed to escape. If there is a data access between the acquire and release, they must stay there. So in this situation, if there would be an acquire here, the B is not allowed to be read into a register before the acquire. Okay, and if we want to translate the Linux kernel to use standard C, or in a similar situation, it would be prevented from reading this global variable before the acquire here. But if we, as we will see very soon, would use something called memory order consume, then the compiler will be allowed to read B before the consume.